So that variable b2 is initialized to null. The default value is null. All right. So now we'll move down and take a look at this thing. The first thing I do is to take the null value and set it to b3 and b2. All right. Now, the question is, what value is true and null? And, you can try to make a guess. And here's the reasoning. For an AND to be considered true, both inputs should be true. So if one input is true and the other input is null, there's not enough evidence to say it's true. There's also no evidence to say it's false. So the value logically is going to be null. So true and null, probably null. Okay? Let's try true or null.
True.
True is logical and correct. And it's nice when there's a non-empty intersection there. Yeah. So true or null is true. All right. So I have this little if-then-else thing trying to figure out what B2 is. And according to our logical meanderings, it's probably going to print B2 is null as the value of true and null. Now, what I also want to do is look at the conditional or the alternative or the if then else, if you want to call it that. All right. These guys, when they got around to PLSQL and seen a few programming languages come and go, and I thought they took advantage of that opportunity and they did some nice things. So if you have an if, you've got to have an end if, and it's pretty easy to remember that it's an end if. For pseudocode, I use fi, but this is real code. Okay. The other thing worth noting is that you can have as many of these as you want. And I like the way they did that. By putting in an else if, you don't have to nest and say else, carriage return, 80 tabs, if. Okay? This is a nice way to do an if then else, to enable the if then else to act as a case structure. Yes.
Else if is the parentheses part.
What's that?
There's parentheses only on else if.
There's only, I still didn't hear it.
Parentheses on if and the else if.
Ah. Yeah, and I'm not going to worry about those details.
Very cool.
One thing that is, I think you'll probably find that the word then is mandatory, which in languages that you're used to, it's not. So, if I ask you about keywords associated with the conditional, you've got a long list. Now, you can nest, obviously. After the word else, you can do a carriage return and start another if. So you can nest if you want to, and sometimes it's necessary, right? It's decision tree kind of stuff. But if what you're after is an imitation case structure, this is the way I like to see it done. Okay. All right. So there's some question whether or not this will compile. Yeah, it should. It did in the spring, and it hasn't been that many months elapsed. So we'll go down to the bottom of the next thing we do is set B to B3 and 3 less than 2. The current value of B3 is true. 3 less than 2 doesn't sound true, so it's probably a true and a false. I'll probably say that B3 is false, unless we missed something, which we probably didn't. And then finally, there's a DMS output dot put line all by itself, and if null and false equals false, say hello. Okay. So is it going to say hello?
Yes.
It ought to, logically. So we're hoping that, you know, the intersection of logical and what it does is not empty. Yeah, generally speaking, if either input to an AND is false, it can figure out that the answer is false. All right? So I think that last one is going to be hello. All right? Well, fine. So now, in theory, what I'd like to do with this is, I'd like to run it. All right, that means clicking on this and clicking down here and saying start PLSQ5, I think is what it is. Should be printed right up there. Yes, PLSQ5. And we'll see what it has to say for itself. B2 is null, B3 is false. Hello! All right. So, good enough. Let's try 6. Our little friend here, upload. Oh, I have to select. Yeah, I have to make that go away, then do the upload, then do the choose, and then do PLSQL6. There he is. Okay. All right. The interesting thing, again, is between declare and begin, where we declare myEmp to be emp of O2 % row type. Now, what we saw last time was % type. And we said that % type was an anchored type. This is the second of the 2 anchored types. So this is another anchored type. In this case, what we're anchoring to is the entire row or tuple, whichever you want to call it, of the table emp. Okay? The employee table. So my emp is supposed to hold a row from the employee table, an entire row. That's its job. All right, so the 2 anchored types are % type and % row type. Fine. Now we do the begin stuff. There's the usual select with the mandatory into. The usual rule applies. They expect us to bring back precisely 1 row, not 0, and not 2 or more. And this time I'm not going to play. I proved it to you last time. Exact fetch returns more than requested number of rows. Right? And you didn't have to memorize that for tonight. Just next week. Or maybe not. All right. So I'm getting down to 1 row by picking on the employee number I'm able to remember. It's the only one. And then we output it. And myEmp is a row, and we can use dot notation to pick out the fields, which is, you know, if you had to make a guess, that's probably what you would have guessed would work, and it does work. Okay. So then we grab 3 fields out of the row, we could grab any of the 8. And there we go. All right, so we can use select into to read either specific fields, as long as they're all from the same row, or the entire row, in which case the best way to do that, because it's a lot less typing, is percent row type. We can try running this and see if that output line works. VLSQL 6. The declaration of this type of, it didn't like anything about this. Why not? Because I don't have a table yet. So, we'll, you know, you can trust me that it runs, but let's get the table. I wonder how many tables I really need to load. Well, I'm gonna be, you know, doing this all the night. So, let's see, I have to click this first or it'll get mad at me. I need to upload a file, thank you very much. Choose a file, we'll try to do that. I need to go up 1 from here. Is there an up arrow anywhere? It would be nice if there was. All right, we'll tunnel down. I'm on the wrong drive. Removable disk, thank you very much. CS514. Gosh, that's wonderful. We only have to do this stuff once. We'll get the tables read in and then it will be done. Terminal, thank you. Start, yeah. There we go. All right, that's one. It'll go faster now. Click here, click there, click here, click there. Let's get info. I know I'm not gonna need sales, or we'll get depth in case I do that.
If we get homework 1 SQL, we might put all the tables.
Not, I don't have one that just has all the SQL in it. So unfortunately, I have to do these a bit at a time. Yay. Start depth. Oh, well, it didn't notice. Make it 0 too. There we go. Not that. All right, we got 2 out of 3. Do this, do this, do that, and try to find info. It should go back to the same one as before, in theory. There he is. Open, upload, terminal. All right, we got the tables. Now we go back here to PLSQL 6. And now it shouldn't get angry with us. Now we should be able to get this sorted. So here we go. Start PLSQL 6 one more time. PLSQL 6. Start is not good, and it's a fussy beast. There we go. All right, so that one works too. All right, the significant thing, like I said, is the second anchor type. So to make it more convenient to read in a whole row, because you wouldn't want to set up 8 variables and, read into 8 variables. That wouldn't be any fun at all. All right, so click on this, click on that, click on upload, click on choose file, and now, right, we're back to PLSQL. Thank you very much. PLSQL 7, if there's a 7, there's a 7. We'll take a look at it. It's good that I have to do all these clicks. It gives you time to make notes. All right. I'm not even going to run this one. The purpose of this is to just show that the usual bells and whistles work. You can use NVL, you can use 2char, you can use anything we've ever talked about. All right, so I'm just going to go get another folder. That one was boring. Important, but boring. It's nice to know that that works. That was 7, as I recall. Let's try 8. See what this one is. Okay. So I showed you how to use the nested if then else with if then, else if then, else if then, else then, end if. This is case when. I don't see any reason to run this one either. But I showed you that you can use this as an alternative to decode in just normal SQL. All right, so the case structure exists in both SQL and PLSQL. Hallelujah. Okay, we'll upload another one. Let's see if there's a 9. I hope not. Yay, it stops at 8. All right, I'm going to upload record.sql. And we're going to take a look at this one. So there are the usual types, namely the Oracle database types like date and varchar2 and char and number. And in addition to that, we found out that there's Boolean, which isn't an SQL type. There are non-scalar types that are possible, so in that sense, this is not a complete toy programming language. And there are, 2 non-scalar types, and this is one. So the syntax is declare type is record. Is record, those are keywords. I don't know, there's some pattern to which ones are in dark blue and which ones aren't. But type is record of the keywords. And it's just, a parenthesized, comma-separated list of the fields in the record. So I have 2 fields in the record. They're both anchored types. Local variable names for last name and salary, called rec name and rec sal. Now, having established the type by defining the type, I can then use that type to declare variables. So what we're doing here is saying second guesser is a type rec type. So second guesser is a record with 2 fields. All right. And then just to show that you can do what you can do in a normal programming language, you can combine stuff. And I'm gonna spend a lot more time on tables later. But this example does show you the other non-scalar type, which is table of. So table of guessers is table of rect type, because rect type is my guessers in my mind. And then there's this ugly piece of syntax to remember. You can use an index with a table, and you have to type the index explicitly, and its type is binary integer. Annoying to remember, but there it is. Okay. So I have a record type called rect type. I have a table type called tab of guessers. And then I create a table called noisy fans, whose type is table of guessers. All right. And then we do the begin thing, and we find out what this looks like. I've got other examples of tables, because tables are a lot more complicated than we're looking at here. Anyway, so second guesser is a concrete record. And I'm gonna, make the name Joe, and I'm gonna pay him $2. All right, we don't pay these guys much. And then I start on the tables. Oracle is very generous about what you can use as an index. It should look like a number. Yeah, they can be negative, they don't have to be consecutive. You can bounce around. It's a wide open season on indexes. Anyway, so the first entry in the table is noisy fans 1, because noisy fans is my table. And that's just going to be second guesser, because I set second guesser up to be a record, and this is a table of records. Noisy fan 2, I'm not going to give a name to, but all right. So I've got a table of records. So noisy fans 2 is supposed to be a record. It has 2 fields, rec name and rec cell. I'm going to make that Mo and pay him more, because you should pay Mo. Okay. And all right, fine. And then I did a -1, and Sue is going to get paid null, I guess. Not going to get paid much. Okay. Well, that's just to show that initialization is about what you think it should be. Right. So let's see, noisy fans 2, that's Mo. So we're going to give this guy the name Hindsight Mo. All right, you see, it's sort of like the San Diego chicken. He's an auxiliary person, not really on the field so much. All right, so Hindsight Mo is the official second guesser for the team. So the idea is that when you go to a baseball game and you actually buy a ticket, you feel entitled to yell abuse at the visiting team and the home team. So if you think the manager left a pitcher in too long because he's given up 13 runs in the first inning, then you can make some very negative sounds. All right? And Hindsight Mo is the official guy. We hired him because when he yells, it's about 37 decibels. Well, all right. Try to get the fans involved in the game. So we can run this just to see that this stuff compiles. So we'll do terminal, and we'll try to get where we can see this. Let's try here. What was this? PLSQL 8? Maybe. No, record. start record. And there it is, hindsight mode. And these are, of course, the magic words that you'd like to see. And we'll be looking at similar things as the night wears on. I think I'd like to do the tables and then take a break. Some of you had little breaks already. Click on this, click on that, click on this, click on this. Try to find table. PLSQL table.sql. This is a harder one to take notes on. All right, such as it is. So last time we had a straightforward table of simple records. This is a table of strings. Okay, so this is a table of scalars. We still need the index by binary integer, and having defined the type food, I can create a variable of type food. And I picked SP chow, okay? Short print chow, or whatever this might stand for. All right, so anyway, the first string is beef taco, chicken taco, goat taco, spaghetti, carne asada burrito, and away we go. The food gets slightly fancier at the end, and of course, I wanted to show that a big index worked. We saw that -1 worked. So if SP is Spanish, then SP chow 4 looks a little out of place. All right, which is why my next line deletes it. All right, we're going to take that off the menu. So delete is a special function that works on a table. And we're going to see more special bells and whistles as we go down. Yay. SP chow dot first. Okay, a table, if you like, comes with built-in zero array functions. What first does is return the smallest index currently in the table. It doesn't return beef taco, it returns 1. But of course, if there was a -8, it would return -8. All right, so I'm going to return first, and least index is, see, I was a good kid. I said least index is to help you remember that what these zero array functions work, and you don't even need parents, or you're right. It's like predefined data members, if you want to think of them that way, except they're variables. So they're really zero array functions in my mind. Anyway, last is going to be the highest index, and the highest index is 1500. So this should return 1 and 1500, and we're not done. Next is a one array function. Next 4 means the smallest occupied index after index 4. Now, the smallest occupied index after 4 is 8. So this is supposed to return, according to me, an 8. Yippee dippy do. All right? Now, if I were doing this, I think I would have stuck with 4-letter words, but they're not all 4-letter words. So they use prior, it's a full word. So this is the index occupied by the largest such index, which is smaller than 1500. And that's going to be 14. So it will return 14 instead of paella. These are both fish stews, in case you're wondering. South of the border of Spain. You might find occasionally a menu with both of those on it, but yeah, hey, you've seen one now, you've seen it here. Okay. A little bit more playing. There's a function called exist with one parameter. I can ask whether or not the index 4 is currently in use, and it should return false because I deleted it. That was spaghetti. All right. So I set a Boolean and then probably output something accordingly. All right. What else are we doing down here? All right. This is important stuff at the bottom. spchow.first returns the smallest occupied index. And then we can go on a loop so that I can print out everything in the table in an easy, slick way, even though these tables don't have consecutive indexes. All right, so they had to make some provision for that. So I'm going to return spchow of first. I'm going to exit when my index working through the table hits spchow last, which is going to be 1500, because 1500 is still in there. And then there's our next function, which we met before, which simply moves us to the next bigger occupied index, as it did before. All right? Now, we're also seeing a PLSQ loop, and the keywords there are loop and end loop. So there's if and end if, case and end case, loop and end loop. Okay. Now, the thing to note about the loop is that it is it's what I call a middling loop. Do while is leading, repeat until is trailing, exit when is middling. It's neither a leading nor a trailing loop, right? And so I can arrange to leave at any time I want, and in this case, you know, I leave at 1500, index 1500. All right, so that's the syntax for loop. Loop, end loop, exit when. Okay, well I said there was a lot in this example, and there is. So we can, you know, slowly look at it. And you're supposed to know these special effects. You know, delete, first, last, next, and prior. Plus, we've now learned a logical loop, a logical middling loop. All right, I'm ready to run it, or, you know, hope that I can. PLSQL table. Here we go. Okay, least is 1, greatest 1500 as predicted, after 3 comes 8, before 1500 is 14 as predicted. Existence of an element with index 4 is false, and this shows that my loop seemed to have some success. It got both beef taco and ceviche, so I think we're good. Right. Later in the class, you're going to learn something that everybody in my class learns. Besides the fact that Robinson's uniform number is 42. Everybody who takes this class goes away knowing that I don't like sushi. But ceviche is raw fish. So, yeah, maybe you don't want to generalize. Anyway, we'll come to sushi later. I have a second table example, so let's try to get that one done. Click. Clickety click clack. And we'll see if I can find this thing. There should be a table 2 down here at the bottom. There he is. And there might be even one more that we could do after that. Anyway, we'll take a look at this. Okay. So, you know, the serious stuff is in here. There's another loop and loop, and I wanted to sort of, you know, call your attention to where's the loop? Anyway. This loop is the one that I wanted you to see in action. There actually is an iterative loop in addition to the logical loop. And I'll show you a variety, a variant of that. So up here, I'm figuring out, how many rows there are and whatever it is we're doing. What are we doing? We're doing department. All right. Okay, fine. So we have the second anchor type. We're getting rows in the department table. That's what this thing is capable of doing. This is how many rows there are in the department table, and we're going to put that into a local variable too. And then we're going to do these two iterative loops. And the syntax is, I think, the same as it was in Pascal, but it's been an awful lot of decades. So 1 dot dot upper bound, lower bound dot dot upper bound to give the range of I, and I will increment by 1 when you do that. So this is a form of iterative loop in which you go up by 1. There's another one in which you go down by 1, and I'll show you what that looks like in a second. Here we're doing, something sort of cheaty. I'm counting. I'm trying to go through the departments, so I count from 1 to 5 and then multiply by 10. So I go through the departments 10 through 50. So that's all that's going on here. All right. All right. So I'll email you this. We can run it. It doesn't take that long to start. And then there's only one more that I want to do. PLSQL, table 2. And anyway, so all those iterative loops also work. All right, now, like I said, there's, I think, one more that I want to look at, and then we'll take our break. Choose file. I'm looking for control.sql. There he is. Open, choose, open, upload, blink. All right, now, here's the deal. Let me pull this down so I can point. This strange looking piece of syntax, less than, bigger than, outer in the middle, that's the required syntax in PLSQL for a label. Hey, it's like the Fortran days and the COBOL days. We can have labels. So the intention here is that I've got an outer loop and an inner loop, and I want to be able to control which one I go back to or which one I exit from or whatever. And so my intention was to put a label on the outer loop and a label on the inner loop, and I chose my labels with sort of appropriate names. All right, so that's what's going on there. I wanted you to see what labels look like. Now, the other thing that I wanted you to see in this example, I'll link this on the screen, and you can try to figure out what the output is if you just want to stay sitting there and think. All right. And that's this variation in the iterative for loop. I told you there was a way to do descending order counting by one, and this is it. The keyword reverse. So this is going to go from 10 down to 1. Okay, isn't that exciting? I don't think they have a way to count by twos. But you can go up by 1 or down by 1. If you want to count by twos, do what I did. Multiply the index by 2. Okay? All right. So this is sort of the end of the story about PLSQL. It is, as I indicated, a very simple language. We have seen a major inconvenience. You can only read in one row at a time into the programming language from a database table. All right? You can only access one tuple at a time. What we'll talk about after the break is how to get around that problem. All right? And so there is a way, and it's a sort of a typical database way. So are there any questions? Quarter up. That gives me just